All right, time for me to intervene. This is how I get my time in the limelight. Here's a quick question for you all. And for all those whom I've asked this question before,
Oh.
why is a screensaver called a screensaver? All of you have a fancy screensaver? For people who know the answer, let's give others a chance. Especially people, where are my favorite collegians who are out of college? Wait. Ah, there they are. I've been troubling them since yesterday. But here's a question for you all. Why do we have a screensaver? And if somebody can come and tell me later on why a screensaver is called a screensaver, I will personally introduce you to Siddharth Sharma. And where we'll get a lot of gyan for all the kind of things that we take for granted. Aniket, are we still good to go? Are we reliable?
Good to go.
I'll have to start telling the story about a screensaver here.
Yeah, we can. Good to go.
And you're good to go. Who?
So yeah, I'll go quick. So hey guys, my name is Aniket Rao. I work as a developer evangelist at Last9. I've been working with Last9 for quite some time. But in my spare time, I do play some amateur golf while I stargaze and write code. So yeah, that's what I am. And now what do I do? Like I said, I do developer evangelism, but I'm a long-time Rubyist. I've been writing Ruby code for the longest time. But these days, write anything to get product working. So, but yeah, what do we do at Last9? So Last9 is a company that builds tools to improve reliability in large-scale cloud-native environments. Oh yeah. Okay. Yeah. Okay. I think I've added way too many animations. Let me just cool it down a bit. So yeah, we do also ship a lot of swag. So stay till the end of the talk so that I can share how you can get these swag shipped to you directly and not here. So yeah, coming back to my talk. What is this talk about? This talk is purely about how you can monitor your Rails applications using open source and cloud native way. So yeah. So what are cloud native applications, right? Cloud native applications are applications that if you see yourself running 2 or more Rails APIs communicating with each other in isolated set of responsibilities, then yes, you're running a distributed system. Most distributed systems these days run in cloud native environments. Almost all apps, or rather in this case Rails apps, run in modern cloud infrastructure in some or the other fashion. So let's see how that looks, right? We'll take one example on how things look. So this is one example where you can observe an e-commerce setup purely from a backend standpoint. You have a gateway load balancer where users and devices are making requests, but you just see how much complexity comes into the play when you have a microservices architecture, which these days most people have. I'm not getting into the debate of what architecture is best, but if you observe what each of these components resemble, they'll resemble a stateless API with a database cache, all working in function in tandems and somehow delivering the request to the end user, right? So it looks complex, but I want to leave it at that. But this is just to like give you a mental model on how things look in production. So for these distributed systems to work in a good fashion, what is primarily needed is good monitoring, because now you have a bunch of components over here where you really need good monitoring to observe these things. Rather, I would say effective monitoring. Now let's kind of take a look at what all do we have, what all do we need to do effective monitoring. And in that diagram that I had shown, we can check what are the layers in which we are going to monitor things. We have the gateway layer. Second, we have the applications. Each of those applications need monitoring. Each of those layers have databases, caches, and the underlying servers. So suddenly, monitoring requirements have gone extremely to like up a notch. But I just want to focus on applications here because I am talking about APMs. So let's see what we can do about applications. So yeah. Yeah, so when we monitor Rails application, immediately people are like, okay, let's just install an APM. People just pick off the shelf APMs and drop it in, and suddenly things seems to work and use. And by looking at dashboards and these APM dashboards, you think people get a feeling that there are things working, traffic is coming, but you have some sort of monitoring. But how effective is it is what I want to kind of drill down into in this talk. So with the ease of installation at which you just dropped in by installing a package or a gem, it certainly comes with a bunch of trade-offs that you've just subconsciously made. Now, what I want to get into is that proprietary application monitoring has its own set of drawbacks, right? It can lead to like numerous challenges, including lack of control over what is being monitored, prohibitive costs, inflexible alerting systems. Also, it comes with proprietary data formats, which you have to understand on how to use it. These factors often like kind of impede the full utilization of monitoring data, kind of stifling system insights and also posing a barrier for you to do rapid problem isolation. So one of the other things about proprietary data formats is that with each new platform, you really get, with each of these proprietary data formats, what happens is that these formats are closed source, so you really don't have, you have to learn how they are built, what is the query language, and use it so that you can query the data, visualize the data. So it becomes a learning curve for each, on a day-to-day basis for engineers and other folks in the org to kind of get around with monitoring these sort of data, right? So, but one of the other things that I've observed after using a lot of APMs is that APMs suddenly, when you just drag and drop them, you suddenly have a lot of data that you're looking at. What you're interested in is a fraction of that, but suddenly you're consuming way too much information. This is sort of kind of getting in your way of basically isolating problems. So what you really are looking at is, as a human mind, can you really consume that sort of data? And that is where a concept of Shannon limit comes into play. So 41 bits per second is the amount of data that a human brain can consume. So if you're suddenly looking at way too much information in a critical situation where you're trying to isolate an incident in production, this really doesn't work out well for you. So you really need to look at a subset of very crucial data to make sure you get your decisions right and often mitigate that incident in record time. So that brings me to one key concept that these days I've been, I think Prathamesh and I have been writing a lot about and talking a lot about. There's a misconception about debugging versus monitoring. So the way I would break this into is that people usually use APMs to kind of start debugging, whereas it's purely a monitoring tool. So when you break down certain facets of monitoring, you will see metrics, events, logs, and traces. Metrics and events kind of give you a headway on where the problem is and what the problem is. How did that problem occur? All of that are the information that logs and traces give you. And I'll give you a very simple example, right? So in one of my previous organizations when I was working, out of nowhere on a sudden afternoon, I saw 70% drop in my order delivery rate. And I was on call that day and I panicked. Like, my metric dashboard clearly showed me something went wrong. I immediately started going to the logs and trying to see. Logs are like, okay, we are good. Traffic suddenly dropped. No information, no errors, nothing. But what happened? I was absolutely clueless, only to figure out that I was new on the job and I was straight away put into production support, only to realize that the region in which this happened, it started raining, hence delivery drivers couldn't go out, hence the delivery rate dropped. So this became an event. This happens frequently in different systems. So understanding events is also a good head start when you get to click, oh, it's raining, hence I saw a drop. Do I really need to go and check my logs? So monitoring metrics and events really give you a head start in a way on how you can monitor things. So when I say that, like when you're looking from a monitoring standpoint, metrics really give you quite the edge. And that's why with less amount of metric, you still can achieve what APMs actually give you. So I'm going to go more into how you can dig deep on how you can utilize metrics. But yeah, so what I also wanted to kind of talk about is that given these inefficiencies of APMs, it's like I've been thinking and for a long time that how we can build, use or rather utilize the concept of application performance monitoring without installing an APM tool. Rather, build this out using open source. And when I say build, I'm just trying to use existing software. I think yesterday someone gave a fantastic talk about how use existing software, right? So that way I wanted to use open source. And why open source? Because open source invites for standardization, right? Standardization is very important when you are dealing with metric data because it's not a skill set that you want to teach to everyone. It has to be a standard skill set that is available in the open source space where people can learn how to query data using a single query layer. It's like SQL, how ubiquitous it is in the structured data set querying language. But yeah, this is a open source way of querying is also quite important. But before we kind of think about APMs, I just want to make a quick checklist on what all things that I want an open source APM to consist of, rather give me advantages, right? So one of the things is that I want zero performance overheads, zero complexity, cost efficient, InfoSec compliant, it should be customizable. I don't want to be logged into any vendors. It has to support standardization and have a simple query language. So quite a bunch of things that I'm trying to go for when I want to have a APM that I want to build in-house, right? So what I wanted to kind of focus on is that let's see what happens when you have, oh my God, this is going wrong. Okay. So let's see what an anatomy of an APM is, right? We have instrumentation, ingestion, storage, dashboards, and notifications. If you break down an APM, it purely consists of these 5 things, which is just given you as a package tool. When you just install it, it becomes a plug and play. That's the trade-off you make, where you really don't have to go through these layers of thought processes on how you can instrument these things, right? How you can implement these things in your, rather in your engineering organization. So what I wanted to kind of do is that when it comes to APMs, within these 5 layers, you build what you want to control, but buy what you don't want to control. So each of these layers that I spoke about you can make a decision on these. But APM tooling is, when you go for proprietary tooling, it gives you all of this, but at a cost, right? So given this, I just want to kind of rethink our options, right? So let's see what I have for instrumentation, right? Sorry for this, but this is written OpenMetrics, if you guys can see it. So for instrumentation, I just want to follow a standard which is out there in the open source world called OpenMetrics. OpenMetrics is kind of the de facto standard for transmitting cloud-native metrics at scale, which like this supports all text-based representation and Prometheus exposition formats and all of these things, which are very standard, and a lot of people have spent their time and energy on kind of building this format out, right? So instrumentation, I want to use OpenMetric format. For ingestion and storage, I have an open source tool such as Prometheus that I can use. And any tool that supports Prometheus formats would also work in this case. One of the key things about Prometheus is that the way it is set up, APM's data constantly push your data from your application to their servers. But Prometheus is part of that architecture which scrapes data at intervals, and after scraping it puts. So timestamp-based ingestion is purely happening after scrape. So you have real time series data, which are far more accurate, and you can store it in a time series format in Prometheus compatible databases. So when it comes to querying and visualizations, right, I prefer to use PromQL. Again, PromQL is an open standard way of querying data. And I also use Grafana. I think a lot of you may be familiar with Grafana. It's an open source visualization tool, which you can just write PromQL in and build your dashboards. Not just PromQL, it supports multiple other data sources and languages. So the other section that is out there is that you have alerting and notifications. Now, not everything here is open source, but these are again tools that you want to buy. Hence, I say, like, you never will build your own notification delivery mechanism. You would rather use PagerDuty and Slack. But you have open source alternatives such as Alert Manager and VM Alert to kind of set your alerts on and build your observability stack on, right? So going through the monitoring architecture, right? Now you can see it looks quite complex, but it works very efficiently. You have your applications, in this case, Rails applications, which are distributed in nature. Your Prometheus server is pulling these metrics. It also refers to the service discovery part, right? For example, you have order service. Order service is running in 10 different servers. So it needs to dynamically understand if you're running 10, tomorrow I want to scale up to 20. Service discovery takes care of that part and figures out how many servers are running and scrapes the endpoints of each and every server and brings that data to its storage system. Now, once that is done, it also has support for exporters, but I won't get into exporters right now. So Prometheus stores its data internally, from where you can use PromQL to query your metric data and create your dashboards using Grafana. At the same time, you can implement those same queries in Alert Manager, and Alert Manager takes care of where you want to dispatch these alerts, Slack, PagerDuty, Opsgenie, whatever you want. So again, using just open source tools, we can cover this thing. But one of the fundamental things that I'm going to address here is that how can APM data fit in this, right? I want to ensure that my application is emitting the same amount of data that I get to see in an APMs. Also considering one important fact, I also want to drop one line of code or make one package. That's all the change I want to make. So let's see how we can achieve that. Before that, I just want to give you a quick mental model of how data looks like when you're specifically dealing with OpenMetric formats, right? You have a metric name. Metric name consists of this ultra scalable label value, key value pair configurations. And at the end of it is the value of the metric, right? For example, this is a metric that is from, that is actually generated. It is HTTP request duration milliseconds count. This is the name of the metric. So now I have filters such as, or labels such as program, path, method, status, environment. Now think of these as label sets that you can control when you are instrumenting your applications. And APM just assumes basic things and gives you. But tomorrow you have control, so it can suit any of your requirements when you're trying to do your own monitoring. And of course, 9.0 is just the value. What does this entire metric mean is that the number of requests I got at that particular time frame, I got 9 requests. That's how I read data, right? I think everyone is cool with this mental model of data. Yeah. Exactly. The metadata of this metric, right? Yeah, that's all. So you can fit that metadata and correlate that to your applications. Store whatever you like, but again, you will run into some challenges, but I'll cover those later, right? So what are the also metric data primitives, right? You have counters, histograms, summary, and gauges. I'll just leave histogram and summary out of this because counters and gauges are the most commonly used. Histos are also, but it's a difficult concept to explain in the time that I have. But counters are nothing but the number of requests that you keep getting in. Imagine a click counter that is like, you're just pressing it, is incrementing 1, 1, 1, 1, 1. And that's the number of data that it sends per minute, per 5 minutes, whatever you want to configure. Scrape intervals are entirely configurable by you. The same way, gauges are fixed values. For certain data sets, you want to just say that this was the value, point in time value of this metric, right? You just push in that value and gauge will emit that value. Histogram is nothing but a distribution of time-based values, like anything that you want to measure. For example, latencies. Latencies are always measured in histograms because when you have histograms, you can do percentile-based calculations. This is how your derivations on P90, P99 are the terminologies that you use when you do latencies. This is how they are computed. So these data types are quite native to any tool, monitoring tool that is out there. So one of the things that, given all of this context, right, I think we at Lasan have been kind of wondering on how we can make open APM or other APMs better by keeping it open, right? So we just, as of today morning, release support for OpenAPM Ruby. Now what does this do, right? OpenAPM Ruby is a simple gem that you can install that will auto-instrument your rack server, rack application. So this applies to any rack-based applications, including Rails. So basic support for HTTP metrics, you get it out of the box just by installing this gem. So, and that's part of our only release as of today morning, but obviously we'll support more and more things like custom metrics, database metrics, and all of these things. So, like I said, it supports rate, error, and duration. The rate of requests, error rates, and the duration of those requests. But what you can control is the label sets, right? For example, the number of requests you're getting. Rails usually will follow a REST-based architecture. REST values where you have resource values, resource IDs, right? So all of these things will be auto-masked and you will not run into cardinality problems when you emit that sort of metrics at scale. So now this exactly here is where the OpenAPM sort of fits in this diagram, right? So the only change I'm making here is that, hey, I've just introduced a library to fit all of this picture to ensure that you can now monitor your applications open source way. Once you do that, what happens is metrics get emitted in the slash metric endpoint. The slash metric endpoint is nothing but an endpoint that your Prometheus services it keeps calling at an interval that you kind of give it. Per minute basis, it will just go grab, go grab, go grab. Once it grabs, it will go and store the data in Prometheus servers. After that, it's available for you to query. So yeah, this is about the architecture, this thing. So let's see how the dashboard looks, right? So one of the APM dashboards that we created, and this is pretty much a cool thing, right? I've just emitted 3 metrics. Like I spoke about how minimal I want to keep, like very less. This is literally 3 metrics that I'm doing: rate, request, number of requests, error rate, and duration. Based on this, look at the number of insights that I can get from a dashboard standpoint. I can do my latency-based calculation, P95, P99, P50s. I can calculate my AppDex score, my success rate, my error rate, throughputs, and also over here, the 5 most time-consuming transactions. So if any API that is performing slow, now I have full control over PromQL to write this query to achieve this monitoring data. Now, at the same time, these same queries can be applied to an alert manager, and the second it hits any threshold, like you want to say that my P99 for order/last should not be more than 50 ms. The second it goes above 50 ms, it will alert you. So now you have flexibility on exactly what you want to control, and you are not dependent upon someone else's thought process on how your applications should be monitored. And this is pretty much the entire premise of OpenAPM, by the way. So let us go through that checklist one more time. So we have 0 performance overrides? Yes, and I'll explain how. Because this is a very lightweight wrapper that you've written, not installed anything more than that. If you open the OpenAPM code base, you'll see very small, one line of code that is just measuring, rather it's just a gauge that is put in which is measuring a request. Part of measurements, it will grab the number of requests and also the value of that request. If it was a 5xx, it will know. So essentially a very thin line of code is just monitoring all of this continuously. So performance overrides are nothing. 0 complexity, nothing. You just drop in this package, install it, and you have, you're good to go. Pretty similar to any APM tool. Cost efficient. Are you paying anything for it? Nothing. It's just open source data. You're just setting it up in your open source based monitoring setup. Obviously, when you talk about storage of monitoring setups, costs, etc., come into play, but very, very significant when it comes to paying for other proprietary based tools. InfoSec compliant clearly, because nothing is going out of your VPC. It's fully, no data is going out into the internet. It's just being circulated in your own VPC and you're just keeping it in your own storage layer. So whenever you query, your Grafana dashboards are within your VPC. So no requests are going out of the internet. So very, very secure that way. Customizable, yes. Dashboards, you can create n number of dashboards. That's the beauty of Grafana. But with PromQL, you can just go crazy and create any dashboards that you want and drill down to the insights that you really want. Right? No vendor lock-in, absolutely not. Everything is open source here. There is no vendor that you have to be tied down. Tomorrow, this makes you in fact better. Right? Tomorrow, if certain aspects of your stack you want to go and buy, you have to look for some vendor who complies with open standards. That's all. So in the monitoring space, pretty much everyone is compliant. But this just gives you to run things at your own end. But should you want to make a buy decision at one of these layers, you can go and do that. Other is standardization. With OpenMetrics formats and PromQL, right? OpenMetrics format allows you to ingest and store data in one standard way. PromQL allows you to query data in one standard way. So querying and ingestion are both very, very open. So these are, they're just standardized for simplicity. And again, a simple query language such as PromQL solves a problem. We just don't have to write anything fancy. If you spend about half an hour to 45 minutes, you'll get a very quick grasp of how PromQL works. It's similar to SQL-like, but think labels and filters built in, right? That's all. You have your min, max, aggregation functions and all of these things that you can use. So that's about it when it comes to the OpenAPM part of things, right? Now, one of the things that I want to close is that when it comes to APM, it's always an afterthought, but I feel that monitoring shouldn't be an afterthought. It should be the foundation upon which your software is built and not something that you throw at it or rather bolt it later. So that's about my viewpoint on how monitoring should be. And this applies for any Rails. For the longest time, I've been using Rails apps and I've thrown an APM at it and thought it solved the problem. But when things scale, when you're really running things at scale, you really need this fine-grained control. But how optimally can you do it and how cost-efficiently you can do it? This is the way to go. So yeah, you saw a lot of t-shirt stickers, right? This is the link that you can quickly access. Just post a message, Prathamesh, and I will ensure that you will receive your swag box at your address. Do note that link. And thank you, folks. Also, yeah, if you're interested to do a deep dive and just discuss, find me outside. I'll happily explain how this can be done in detail. But this talk was very quick. I can understand, but yeah, happy to kind of explain it in a detailed fashion. But yeah, that's about it. I am
Questions?
open to taking questions.
Okay, I have understood about the cost efficiency and all those things simple. But how about maintainability? Like if I choose a Datadog kind of an APM, I don't want to maintain it at all. And
So,
for
sorry,
here,
can you just repeat that? If
maintainability.
maintainability, okay,
Yes.
yeah.
So when I choose an APM like Datadog or any third party, I don't want to focus much about it. Rather, I'll do about the core business stuff. But here, I have to keep the all the services to be ticked in. I have to put an extra effort on like, the additional DSL,
Correct.
and I have to give access to my new developers to learn all those things. And we have Slack integration. So I have to basically keep all those boxes ticked in so that I have a good maintainability.
Absolutely.
Rather in other a regular APM, I don't want to do that. So how do you compare this?
It like it depends, but one of the ways that I would say that you can start your journey with built-in APM tools, because clearly when you're building a software for a business, your focus is entirely on business and product, right? You really don't come to this, but these things blur up or rather get exploded in cost. At that time, you tend to make a decision which direction you want to go, because you cannot keep paying that cost, because observability and SRE becomes a cost center to your business. There is no way your finance guy is going to allow expenditure like this. So that's the time you'll have to come and think about open source solutions. So here is me who's kind of giving you this head start, like go this and try doing this and see if this works out for you. But surely it is going to keep your finance guy happy.
Great, okay.
I have another question.
Hi, Anubhav this side. The question is this slash metrics endpoint that you talked about. So, like, I just wanted to know about the gem that is. How does it collect that metrics?
It just exposes a endpoint, and so basically under the hood, how this works is that you have a Prometheus client library, right? All it does is that it instruments a rack. At every request that is coming in, it will go initiate a duration request. Once it wraps that, it's going to capture the number of requests that came, the errors, and the latency value that was there, and
So
it's going to put it
wrapped
into
around rack only.
yeah, it is just going to put it into a registry. The registry is mounted onto your slash metric endpoint on your routes. That's all. So that's all it's exposed.